I'd like to thank you guys for the opportunity to try out a new talk, which is this one, introducing APIs. APIs are a big part of building software, and I think learning to build software, you're going to run into this concept, and I wanted to make it. I wanted to give a chance for people to understand really how they fit into writing programs. So I'm gonna take us on a little tour of this idea of APIs, of the history a little bit of APIs, and then at the end, since this is my first time giving this talk, I really would like anybody who got something from this talk to come back and ask questions so that I can continue to improve the way the talk works. Maybe add in some things that weren't there for you. So please stay after and bring what you have, and we'll have a chat about APIs. So let's start with just this notion of what is an API, right? Many of you already know what it stands for. The I stands for interface. It's an interface. Well, let's think about what interfaces are, and to help break this idea out of just this sterile world of software, I'll start with the interface for making a peanut butter and jelly sandwich. So think about just on your end, what does it take to make a peanut butter and jelly sandwich? What are the steps you'd take? Right, you're writing a program to make a sandwich. In this case, your program is going to run on the very complicated platform called the human body, right? So you're going to walk into your kitchen and you're going to have to, let's just imagine that what you came up with is you're going to get some peanut butter and a knife, right? You're going to get some bread. You're going to get some jelly. You're going to spread the peanut butter on one piece of bread. I don't know if this is how you make yours. You're going to spread the amount of jelly, and I know there's a lot of, maybe not everyone agrees on how much jelly goes into a peanut butter and jelly sandwich. And you may have noticed I didn't toast my bread, right? So you're going to spread the jelly, and then you're going to put it together, put it on a plate, add some garnish, probably not, right? Anyway, you come up with this series of steps that you're going to do to achieve some kind of goal. I'd like to make a peanut butter and jelly sandwich. So you want to be clear about what is the goal. I want to have a peanut butter and jelly sandwich, and what are the steps to get there, right? Well, APIs come in when any one of those steps, you need to actually go carry it out. So let's say one of those steps is I need to get a butter knife. Well, in your kitchen, how do you go get a butter knife, right? You have to walk to a particular drawer, open that drawer. If it's empty, go to the dishwasher, right? You have a whole series of steps you go to get a butter knife, but I didn't tell you all those steps. I just told you, get a butter knife, right? In any process that we go through in building software or in our lives, right, there's a certain amount of detail we go into, and then we stop, and we assume that however we're going to get that done doesn't matter, right? However you got to get a butter knife, I don't care. Go get a butter knife. However you're going to get your peanut butter, right? I didn't say whether it was going to be chunky or creamy, and I imagine you have some opinions about that, right? But I didn't specify chunky or creamy. I didn't specify what flavor of jelly, right? I didn't give you a lot of details you might need to satisfy that step of the task. Part of what we're doing with APIs is the same idea in software. So APIs provide us this way to express what we want something to do for us, right? And that's what the AP stands for. We're building applications. Application programming interfaces are the part of software that separates what you want to get done from how you're going to do it, right? And sometimes we are using APIs that are given to us. So if you start writing programs, and the beginning of writing programs is you just say, I want to write programs, right? Well, what does that mean? I want to write programs, right? I want to go write some code. This is freeCodeCamp, right? If I want to go write some code, first I got to imagine what do I want to get done, and then I got to get a computer to do it for me, right? Programming a computer is trying to make the computer do some things. So you, the programmer, have to make some kind of program, right? And then give it to the computer, and the computer is going to go do it for you, right? And computers don't know how to make up whether they want chunky or creamy peanut butter. They don't know. If you don't tell them exactly where the jar is in your fridge for the cherry preserves, right, they can't give you jelly, right? They need all the steps, right? So at some point, you stop giving steps and you use another program, right? Programs are made up of other programs. Let's see how that actually pans out in a real program. So you make a computer program. It's got a bunch of steps in it, right? And some of those steps get looped over, and some of those steps have conditionals, and we've seen that a lot of those ideas probably in other freeCodeCamp presentations, right? As you build programs, you get this more and more sophisticated understanding of how to tell a computer what to do, right? And then Eventually, as you're building a program, you might want to break that program up into more than one program. That step, when you break it up, you're making an API. That is exactly what that thing is. When you make a function signature, or when you make an HTTP interface, we're going to look at all the different ways you can make APIs. But what's important at first is the idea that an API is a boundary between one program and another program, right? That's why it's an application programming interface. You, the programmer, are going to write a program, and that program is going to use another program, right? So what does the API say? How you design what the API says is going to influence the way your program is written, right? That step 2 down there, call API, what does that look like? It might say, go get jelly, right? It might say, spread peanut butter, right? But you have to name it something, and that name has to make sense in your calling program. And then how to go do it has to make sense in your target program, right? So hopefully the first thing we've established is that building programs sometimes means breaking programs up into more than one program, right? And when we do that, the line in between them is your API, right? Now I've got a bunch of other vocabulary I want to get clear for this example I'm going to give on API. So we're gonna go through a few terms that I haven't been using yet, right? And the first one is an application. So when we write a computer program, sometimes we call it an application. Now, if we go back and we think about the idea that I'm going to make a program and the computer is going to run a program, right? The application is made up of the source code of that program. And today I have a version of that source code, and tomorrow I'm going to change it some. I'm going to add some steps, or I'm going to break it into 2 pieces, or however my program is made up. It changes over time, right? An application is a computer program that changes over time, and it has versions, right? You build a program, you commit some to Git. Every time you make some changes to your program, that's still the same application, but the program is different, right? A program evolves over time, and the whole time it remains the same application. So we're going to talk about applications from the perspective of a named piece of source code. In GitHub, you would call this the repository, right? So your source code lives somewhere. Your source code is the language you write your program in, right? And the application is the identity of that program as it changes over time, right? So that's going to be how we want to use the word application when we're thinking of APIs, right? So if an application is going to call another application, we make that change at design time, right? And we want to, when we're designing APIs, we're trying to build software that's good, right? And good software is, from one perspective, it's software that does what it's supposed to do, right? That's sort of level 1. Does the software work? Does the program do what I wanted it to do, right? But there's more elements of quality than just does it work. For example, when I go to change it, does it fall apart, right? Or can I change it without it falling apart, right? We call that maintainability, right? APIs help us make software that is more maintainable, which means it's easier to change it without breaking it. It's easier to change it without it falling apart and not working anymore, right? APIs are one way that we design maintainable software, by coming up with a good boundary between one part of a program and another one. And a good boundary is one where when part of the program changes, the other part doesn't need to change, right? That's what we call coupling. So that's design time, right? Runtime is a different element, right? Sometimes we need an API because we want to run part of the program differently. Maybe we want part of the program to run on a different computer, or maybe we want to write it in a different language, or maybe we want to run it on 2 computers instead of 1, right? So if you need a boundary between parts of your program for runtime reasons, we also will use an API. So there's design time characteristics of APIs, which is how do we write code with them, right? And then there's runtime characteristics, which is how do we run that code? And that's where we need to identify this term service, right? So a computer program runs on a computer, right? I make a program, that's design time. Runtime is when a computer runs my program, right? And we call them services when the program is not used by a user, right? If you have an app on your phone, right, you're hitting buttons and the app is doing something, right? So the way the program interacts with its user is interactive, right? Well, some programs are not interactive. Some programs, you just kind of start them up, right? Your computer right now might have a virus scan on it, right? And that virus scan program doesn't always need you to do something, right? It's just going to kind of run behind the scenes and do things, right? Services, that's in our vocabulary section here. Services are programs that go ahead and do something without a user interacting with them. We call them background daemons sometimes, right? So services have a life cycle. Life cycle means you can start them and stop them. You can install new versions of them or uninstall them, right? Sometimes they write log files. Sometimes services run on other computers, right? So a service is the way you understand a program running somewhere, right? So you write applications, you deploy those applications to computers, and now that they're deployed, we call them services, right? Now, there's this notion, and a lot of us are doing web programming. There's this notion of a web service, and this comes up a lot when we do API design, because a lot of APIs we build are for the web, right? So to know what web services are, we need to take a little detour. We need to go into a little bit of history of the internet, right? So let's talk about this thing called the World Wide Web. What is the World Wide Web? We're doing this because many of our APIs are going to be web service APIs, right? So what is this thing called the World Wide Web? Well, the World Wide Web is not the internet. There's a difference, right? If you go back and look, the internet became available and became available to the public in the 1970s. So this is 2020, right? That's 50 years ago. And the World Wide Web did not exist yet in the 1970s, right? The internet was made up of protocols, which are rules for how computers talk to each other, right? That worked over networks, over wires, right? So the internet was born in the 70s, and the web was born much later. The web, I actually have a picture of the web's birthday here. The web was born in 1989. We know the exact birthday of the World Wide Web. There's a guy named Tim Berners-Lee, and he worked at CERN, this place called CERN, which is, I think, in Geneva, Switzerland. I think that's right. It's at least in Europe somewhere. But CERN is not a place to make web technology. CERN is not an internet research institution. CERN, in fact, is a laboratory. It's an organization called the European Organization for Nuclear Research. I like their new website. Where's their new website? There we go. And they do particle physics. They smash particles together and do scientific experiments, right? So it's at first maybe a little surprising that this thing called the web that we're going to use to make APIs, right, was created at a research lab that did particle physics, right? But it actually does make sense. We're going to see here the web was originally a proposal for managing information at this research laboratory, right? And you'll see here this little cloud that says hypertext, right? The web is intimately related to this notion of hypertext. It's what makes it the web, that the text is hyper. Now, you've heard this term hyper before. Some people's children are hyperactive. Some adults like me are hyperactive, right? Or on Star Trek, there's a engine called hyperdrive. It can make you go warp speed, right? Hyper has to do with things going fast, right? So there's something about hypertext that makes the text fast, right? So this thing called the World Wide Web is obviously very important to the way we build APIs. So there's something about this fast text that makes APIs be more powerful when we build them using web services, when we build them on the web, right? And I'd like to make that obvious to you. So let's imagine why he needed to go build this thing. He had the internet already, right? Tim Berners-Lee already had this World Wide Web. He didn't have the World Wide Web. He had the internet, but he worked at a research lab. Now, when you work at a research lab, the information you need to manage is scientific research. It's papers, because scientists, when they do experiments, if they want to use someone else's research, if my research needs your research, I somehow need your research. How do I get your research? That's the information, right? So scientists have come up with a pretty standard way to do this. They write these things called research papers, right? And the research papers, they say what your experiment did and your data and your results, and then at the end they have some conclusions, and that's the research. That's the information that the scientist produces. And if another scientist wants the first scientist's information, then they have to somehow get that paper from the scientist. So my grandfather was a scientist in the 1970s, before Tim Berners-Lee published this thing. In fact, he passed 3 years before, or he didn't pass, he retired 3 years before this came out. So all of the research my grandfather did was radio astronomy. And for him to get other people's research papers, well, I think at the time they had fax machines, right? So if I wanted your research paper, I could call you and ask you to send me a fax. And if you were at work, then you would send me a fax and I would have your research paper and I could go ahead and keep working on my science. And then I go down and I'm reading your research paper and there's a bibliography at the end. And that bibliography actually says that I want Chris's paper because Chris's paper was really about it was really interesting. I didn't know about it before I read your paper. So now I'm in the bibliography and I want to get Chris's paper. So I call Chris's lab and he's not there. So I send him an email. Hey, Chris, did I have your paper? Right. And, you know, maybe tomorrow Chris comes into the office and reads the email and sends me a reply and sends me his paper. And then I have his paper. Right. And then his paper in the bibliography it's using data from Kimberly's experiment. And now I want Kimberly's paper, but Kimberly works in America and I'm in Switzerland, right? So I send her an email, or I don't even have Kimberly's email address. I just have the address of her lab. So I could send her a letter, or maybe it was published in a journal and I could go to the library and read the paper. You could see this is not hypertext. This is regular text and it's slow. I got to wait for people to do things for me to get papers, right? So what Tim Berners-Lee was inventing was a way for me to get the information I want right now, right? So if I want to go read your paper, I just go to a computer and get your paper, right? Now, if you just share your computer with me, I don't know how you organized all your files, right? I could go look around your hard drive and look at the pictures of your kids, but I want your paper. I don't want the pictures of your kids, right? So there's a way I want to be able to tell your computer what to do. Well, he had the internet. He's like, there's got to be a way to use this cool thing called the internet to do that. So let's imagine that your computer is at a place called google.com, which it isn't, right? I need to turn those notifications off, don't I? Let's do that. And so Tim had this wonderful power where he could have a two-way conversation with any computer in the world. I can have a conversation with Chris's computer or Kimberly's computer or your computer, and this connection is now between our two computers. So I can say, can I please have Chris's paper on, I don't know, on gluons? And then the other person can be like, well, sure, what is the title? And then I could tell them what the title is. So there's a way to have this two-way conversation, right? We can have a connection between our two computers. As you can see, that's not a very good API, right? I can't write code that writes English and then answers the questions that come back to me in English. Not Chris, Tim wanted to make an API where instead of typing that, there's a clear way to say which paper do I want to get from that computer? And there's a clear way to get an answer back, right? So what's hyper about it is these nice things called links. I can say get/papers/gluon.pdf or HTML, and it'll give me back that exact paper. And in the paper, if there's a link to Kimberly's paper, I can go click on that link, and there's a program on my side that immediately can get Kimberly's paper. The web spread to the entire world very quickly because it was because scientists who used hypertext were completely way better at doing science than before they used hypertext. If you don't use hypertext, you're terrible at doing science because you got to do phone calls and emails and faxes to get other people's papers, right? That's why this was so important a technology for research labs. Well, here's the problem. He can write a computer program that does this, right? But it only runs at CERN. What if he wants to get papers from scientists who work at other companies, right? And that's what the problem was. So he needed to share this code, this program that listened for papers, that had this neat little API called HTTP with other institutions. And he did. He shared the program, and other institutions had the program, and they all worked on it together. And over time, through trial and error, we came up with the best API for sharing information on the internet, and that API is called HTTP, and it was originally shared in a program called the Apache HTTP server. This program was the original web server on the web, and over time it turned out other people wanted to make servers, so they ended up making a standard called the RFC, HTTP RFC. You can look up, and that's a request for comments that says, hey, how should we do this API? How should we make this protocol work? And people agreed on all that, on the terms and the characters and the links and all of the details of how this API works, because we use it at scale across the internet. And now you and I don't need to go to all the trouble of coming up with the words and the characters and the punctuation for making these programs work together. We can just write what we call REST services. And REST services use this protocol called HTTP, using libraries that we use in our different programs to build higher level APIs. So that's why we use this thing called the World Wide Web to make web services. Web services are good at sharing information, sharing not just data that means something, data that is that allows you to accomplish something else, right? So I'm gonna give you guys an example of using APIs to build a computer program, to build a piece of software that makes so we're gonna look at a program I'm writing, right, that needs to run on some computers, that's broken up into different APIs, and why those APIs are separated into different parts, right? So what this program is, you may have seen it before, is Tetris. There's a game, there's a computer game. Computer games are made out of programs, right? So I wanted to make, and I am in the middle of making a website that allows me to make programs, programs that play the game of Tetris. And that's the name of the website, battleground.ai. And let's take a look at how it works, right? So here's where we're going to need APIs. So when you write a web application or a program that runs in a web browser, you can write it in a lot of frameworks. So I decided to write the web program in React, which is a API for JavaScript that lets you make web applications. And I think you guys have had React tutorials here on freeCodeCamp before, right? And what I was trying to do is make this web application give you a way to write other programs called Tetris game bots that play the game of Tetris, right? So there's two programs here that are kind of world facing, right? I've got a React application, then I've got some kind of program I want to write that plays the game of Tetris. And then I make a third program, this battleground.ai backend service, and that's written in the Go language. And that program does the work that has to run on the server, right? So if you're making a game engine, right, there's the program that is the game server, right? It's where the game actually exists. And then there's the client, which is the Tetris game bot here, right? So this is where we want to look at where the APIs fit into this whole thing, right? So let's add the APIs in. So we've got a program running in a browser, a React application. That's a JavaScript program, and it calls a REST API that is exposed by my backend service, right? And that REST API lets the website work, right? So if you log into the website and you're going to create games and all that stuff, all that has to do something in the backend, right? So you've got the program that makes your browser work, but your browser isn't running on my computer, right? Your browser is running on your computer. So if I want your program on your computer, your React application, to make something happen in my program on my computer, the Battleground backend service, there has to be some way that those programs talk to each other. And I made what's called a REST API, which uses that HTTP protocol we just looked at, right? And that REST API lets this application talk to this application. They can communicate, right? So when you create what's called a ticket, it'll create a ticket in the backend service, for example, right? And then my whole point of this website was to give you a way to write little bots, right? So you're going to write another program in whatever language you want, right? And that program also needs to talk to my backend service so it can play the game. So that needed a separate REST API, right? So one program, in this case, my backend service, can expose more than one API, right? So APIs are things that can be provided by programs. And you'll notice, in order for my backend service to work, I needed to keep my data somewhere. So I have another program called a game data service, which is also in Go. So I made two programs, and one of those programs calls the next program using, again, a REST API, and that program interacts with a data store called Redis through a completely different API, not a REST API. So some APIs are more like languages. You'll know with databases, you type in SQL commands, and SQL is another way to have one program talk to another one. That's also an API. So some APIs look more like languages, and some APIs look more like web calls, but either way, they're ways for one program to control or to get at data in another program, right? Now let's see how we should design these APIs, because you'll see that some APIs, in order to design these APIs, you do different amounts of work, right? So I'm going to add in something that's totally missing from this picture. I'm going to add in the people, okay? So now, in order to make, the reason we need the APIs and we need different kinds of APIs is there's different people involved in the software, right? So there's me up here. I'm the person making the site in the back end. So I made the React application, right? I made the backend service and I made the game data service, right? There's an API between these two programs that I made, right? That's the REST API up here at the top. So that API is, I'm not going to make a lot of documentation for it or anything, right? That API is between my two pieces of software that I wrote. And a lot of APIs we make are like that. They're internal APIs is what we call them. So anytime you make an API between two programs that you're writing, well, the only person who's ever going to use that API is you, right? So you put as much design into that as makes sense to separate these two applications. And that's what I did, right? And that API, it uses security. It uses a JWT token, which is a way to authenticate APIs so that only my application can call it, right? So if you made a program and tried to call my REST API, it wouldn't work because you don't have permission, right? So that's one reason we create two different APIs, is sometimes you want to secure them differently, right? And then the same thing with this backend REST API. Now this API isn't even, you can't even get to that from the internet because it runs on a private network, right? So I can have this program talk to this program and there's no way any other program can even use that API, right? And then that one's going to work with Redis again on a private network as well. The only API here that's used by people who are not me, right, is this person who's making a bot. They make the Tetris bot and they can write it in any language they want. That's one reason I made a REST API instead of, for example, Redis commands. I made a way that for if you want to write a bot in any language you want, in Elixir, in Go, in JavaScript, in Java, Python, I knew that people might want to write bots in lots of different languages, so I gave them a REST API. And for that one, people need some way to know what the API does. So I'm going to show you that one. Here's where you actually need to use API documentation, right? Because for people to be able to write code with an API, they would need to see how to use the API. So you create things called API specifications, and this one's using Swagger or OpenAPI Spec 3. So what you do is you document your API in terms of what are the different paths and what are the things you can do with those paths, and you actually give the programmer some idea of what input the API needs, what output the API is going to give back, and how the output's going to look, right? And this is called Swagger. This is called or OAS3, right? And you can write APIs. Sorry, go ahead. Oh, from my diagram. Actually, Redis does not have a REST API. You got to make REST APIs for your Redis. So let me show that slide again. In this case, I didn't make a REST API in front of Redis because Redis's API is a TCP connection, and actually it's very well documented. It's not only REST APIs that are well documented. If you go to Redis, you'll see the where's the reference? Full list of commands. Their API is commands, and those commands. So let me, for example, get is that's the simplest command. You give it get and a key, and it gives you back an answer. It's very different than REST, right? Because it's just strings in and strings out, right? And that's very well designed for what Redis does, which is all around data storage, right? It's a very fast key value store for data. So this API is not a REST API because you need to use a special Redis proprietary protocol to talk to the Redis server. It's not a standardized protocol like HTTP. Yep, that was good. Thanks for that question. Is there any other question or follow-up? Well, yeah, Q&A is next. Yeah, so let me finish explaining just this notion of API documentation. You don't have to use Swagger like I did. You don't have to use OAS. You could write a web page, right? You could send an email. The point is, if you're making who your API is for, is why you write documentation for APIs, right? If your API is for code that you're writing, then you only write as much documentation as you need, and you keep it in GitHub in your README or something, right? But if you're making an API for other people to use, then you want to document it in some way that they're going to be able to understand it, right? And that I meant that to help highlight these three terms at the bottom. So I think we're ready finally to define those, and then we'll do our Q&A. So when you're building APIs, there's some software that's going to do what the API says. It's going to go get the jar of jelly, or it's going to go get the butter knife, right? That's your API implementation. So on my diagram here, the API implementations are behind the APIs. So my backend service here, it implements two APIs, and this data service implements one REST API, and Redis implements a completely different API. So The program that does what the API says is the API implementation, right? There's another program in my list here called API client, right? The API client is an application as well, right? So in this example, the game data service is an API implementation for the REST API, but it's an API client for the Redis commands, right? It's going to provide a REST API and it's going to call Redis commands. That's its job, right? Where this backend service, it implements two APIs, but it's only a client for one API, this game data service, right? So the program that calls an API is called an API client. And once you write that application, it's coupled with that version of an API, right? Once you write a program using an API, it's done, right? It's only going to work if that API keeps working, right? Finally, there's one more term here that I think is really useful, the API consumer, right? An API consumer is the person who's writing the API client, right? So this person, the pink person, is the one writing the React application. So the API consumer of this REST API is this person, and that's who you write the documentation for, right? The API consumer of the REST API for the game bot is this person who's making a bot, right? Different person. So you write different documentation for them. And of course, the API consumer for the Redis commands is me, but I'm not the one writing the Redis commands, so I had to go to their documentation to see how it works. So that's really all I had prepared on the vocabulary, the client, the consumer, and the implementation. And if we had a quiz, I'd quiz you on those. But I'm ready for the next question. Let's go ahead and move to Q&A, Chris.
Yeah, I think we had a question, Clifford, whether if the question was, wasn't there a company prior that create and maintain the web at a loss because they had to keep it for free?
Yeah. Oh, you like the history stuff? Yeah, me too. Yeah, I think you're thinking of probably. This is dating me. There was a company called Network Solutions, and the part of the internet that they maintained was the DNS registry, and it was moved into a nonprofit because Network Solutions was, and they still do SSL certificates and stuff. That was who you had to go to get your something.com or something.edu or something.gov. So your question makes me think about them. They were the private entity responsible for all of the domain names of the world until it got moved into now it's a nonprofit and it's federated to all the different countries because DNS is so important for the web. But I think that's what you're referring to, unless I'm mistaken.
Question, but comment. Code with Sean says he's well versed with APIs, but he really appreciates your explanation. There's an
Well, thanks, Code with Sean.
Other questions?
Well, I'd like to talk about APIs with you guys, even if you don't want to type them into Twitch. So maybe we can move to the Google Meet call and do questions live. I mean, I think it could be that there's whole areas of the topic to talk about that I didn't think of. So I'd love to have your question.
Oh, there was another one here. Icarus Factor, are you using REST API with two?
I am, actually. That would be a good part, something to present. So for my particular site, it's not the only way to do REST APIs security, but it probably would be a neat little add-on to this explanation. So what I did, and I'm going to plug one company just because it's what I used. I used a site called auth0.com to set up an OAuth 2 to set up an OAuth 2. I don't have my login set up, backend, right? So I can have it let you log in with Google or log in with Facebook, and Auth0 provides APIs that your React application can call and your backend Go application can call, so that they can all share the same authentication information. So I didn't write that part. I just used Auth0 instead. So I used their API so I wouldn't have to write all that security code, which is maybe another plug I can do is when you're writing security code, you want to try to use someone else's that's very well tested if you can, because it's real easy to mess up security code. Yeah.
And the question is not directly on APIs, but they want to find out more. Battleground.ai.
Yeah, that's definitely not related to the talk. Why don't you come to the Google Meet? It's a fun project I'm doing on the side for people to learn how to write reinforcement learning algorithms, AI algorithms. So if you're interested, we'll talk about it in the Google Meet chat.
Yeah.
Or you could just go to the website or join Techlahoma Slack. I have a channel for it called AI Battleground on Techlahoma Slack.
One more question. Standard API.
Oh my, there's lots of standard APIs. That's probably another good area for me to show. There's these different API catalogs, and I was looking through a lot of them this week as part of my prep. I decided not to include them in my meeting just because there's not like one standard API catalog, but Programmable Web is a pretty good one. There's another one called Mashery. There's a number of these websites that what they do is they list all these APIs out there. So like Google Maps has an API, and Amazon S3 has an API. Almost any cloud service you can use has an API for you to be able to use it, right? So yeah, these API directories that are out there give you a way to sort of explore APIs that other people have made and made available to you, and then try to use them. So yeah, there's no like, so an API is at least a web API is exposed by somebody who's got some service on the web, right? So Google might have them, Microsoft might have them, and then little guys like me on my Battleground site have an API, right? And then you can make your own. So as you get to lower level APIs, there are, I don't know of a lot of standards for this kind of API. There's definitely standards for low level protocols like HTTP itself, and there's a whole bunch of those, and you can find those. The consortium that makes those APIs would be W3C, the World Wide Web Consortium, and a lot of the standards that the APIs are built on top of are kept here. And I guess that would probably be wrong of me not to also bring up the IETF, which is where HTTP itself is kept. This is the Internet Engineering Task Force. So the World Wide Web Consortium and the IETF are where a lot of the standards of the webs are actually maintained. And they're both open groups that you can participate in.
Yeah.
Yeah, I see the Redis question. Yeah, it's a binary protocol. That's how you talk to it. It's actually just characters, but yeah.
Everything's binary.
Mm-hmm.
Yeah. Have any? So let's go ahead and end the stream here. And questions, feel free to join in. Call. That's been, or the link's been posted in the chat. Feel free to join us there.
Yeah, we'll see you there.
All right. Thank you so much.